Hello, welcome back. So we're on the next lesson on quantitative chemistry, still working on this booklet. Here's a little bit that we missed out on page 8 to 9. How do we work out the percentage of mass of an element in a compound? Something we need to know. How much of any particular element is there in a compound? Okay. So what we do is we take the relative atomic mass of that element, we divide it by the relative molecular mass or formulaic mass of the compound, okay? And then we multiply by 100%. In mathematical language, as a percentage, simply translates to times 100. Remember, when you do the sum, you put the times 100 up there on the top line of the sum. So you take the relative atomic mass, divide it by the formulaic mass of the whole thing, times 100. And that is it. Have a go at the practice exam question on page 9 of our booklet to see if you can work that one out. Okay. And then the next little bit of this lesson is also very short. It's 4.3.1.3 and it's about, that's the specification, remember, it's about mass changes when either the reactant or the product is a gas, because we know that matter cannot be made or destroyed, but we know that gases can escape. So you could be given a question about this, all sorts of different ways to think about, okay? And really what you're being asked to consider is, are you looking at a closed or enclosed system, or are you looking at an open system or non-enclosed system? In a non-enclosed system, then the gas, whether it's a reactant or product, can escape into the atmosphere, okay? So just to bring a little bit of practical into this, these questions might be about practicals that we've done. You need to think about whether the system is enclosed or non-enclosed, as I say. You need to think about what are the signs of a chemical reaction. Is there a chemical reaction taking place? Is there effervescence? Is there a change of colour? Is there a change of temperature, either up or down? Okay, depending on whether we're talking about endothermic or exothermic reactions. We know all the signs of a chemical reaction, and remember that most chemical reactions aren't reversible. Later on, we'll learn that some can be, but most chemical reactions aren't reversible. So you're looking for signs of a chemical reaction, and then ways of measuring if you think a gas is being released, all right? So if you were given an experiment here, so we've got calcium carbonate plus hydrogen chloride to make calcium chloride, carbon dioxide and water. Obviously, if you do that experiment on a balance, you can demonstrate that the mass is going to go down because the carbon dioxide is going to leave. If you do it on a balance with a glass wool plug, it will be safe, because should the pressure build up with so much carbon dioxide being released, the glass wool plug will be ejected, and also the glass wool plug acts as an insulator if you need one, okay? If you do that experiment with a rubber bunging, then beware, because obviously the gas is going to build up pressure and it will escape, okay? So something to be aware of when you're looking at masses in chemical reactions. That's a very, very short lesson. See you soon.